Hello everyone, welcome to another video session class. So in today's class we will study about the aromaticity and synthesis of pyridine. Okay, so about its aromaticity and how this pyridine can be prepared. Okay, so pyridine is a six-membered ring nitrogen containing heterocyclic compound, and it is having unsaturation. That means there is presence of double bond. Okay, so till now whatever structure we have studied, those were the five-membered ring. Now we are seeing the six-membered ring. This is pyridine. Okay, and here nitrogen is heteroatom. That means total five carbon will be there, and along with that one nitrogen will be there. So let us see start the aromaticity. So under properties, first aromaticity. Okay, so this is the structure of the pyridine ring. So you see here one nitrogen. Okay, five carbon. Okay, 1 2 3 4 5. So total 5 carbon and one nitrogen. So in together it is six-membered ring heterocyclic nitrogen containing heterocyclic compound. Again, numbering start from here. Okay, 1 2, or from this side also you can go 1. That means nitrogen will always the number 1. Okay, so pyridine have 5 carbon and 1 nitrogen. So 5 carbon, 1 nitrogen, all are sp2 hybridized. sp2 hybridization is planar, so we know sp2 hybridized orbital structure is planar, so it makes a planar pyridine ring structure. So overall this will having one plane. Okay, planar ring structure will be there for this pyridine. Each ring atoms also contains unhybridized p orbital that is perpendicular to the plane of the sigma bonds. So there is plane of ring, so sigma bond or single bond constitute the plane of the ring, and the p orbital are perpendicular to that plane. Okay, or sigma bonds. Here p orbitals are parallel to each other, so that due to that parallel to each other, this which forms the double bonds. Okay, that perpendicular p orbital forms the double bond. Okay, so overlapping between p orbitals is possible. So between p orbital overlapping is possible. The total number of non-bonding electron are 6. So it is 5 from carbon, 5 from carbon and 1 from nitrogen. So total 6 non-bonding electrons are there. So then resonance of 6 electrons follows the Huckel rule. So it also follows the Huckel rule. So that's why it is aromatic in nature. So next, let us start the synthesis. So first method of synthesis or preparation is Hunt's pyridine synthesis. So condensation of an aldehyde with 2 moles of beta dicarbonyl compound and ammonia. So in presence of ammonia, this is beta dicarbonyl compound, we condense with aldehyde, so it will form first dihydropyridine. Okay, first dihydropyridine, then next oxidation in presence of HNO3, this HNO3 and H2SO4, it will form aromatic pyridine ring will be formed. So this is aromatic pyridine form from this double bond. It was not, dihydropyridine was not aromatic. Okay, but it is now, it is aromatic. 4n plus 2 pi it is following, and as well as alternative double bond. Okay, single bond double bonds are there. So next, in presence of potassium hydroxide and solvent is ethanol, then next you treat that one with a calcium oxide, so it will cause removal of 2 carbon dioxide. It means from this part. Okay, this part carbon dioxide will be removed, and ultimately you will get 2,6 dimethyl pyridine. Okay, so this is the Hunt's pyridine synthesis. So let us see the mechanism of this Hunt's pyridine synthesis. So first, what will happen? No-ebenezyl condensation between the beta ketoester. So beta ketoester, it is that dicarbonyl compound. Okay, so condensation will take place beta ketoester and this aldehyde. Okay, in presence of ammonia, 1 molecule of water will be eliminated, so it will form unsaturated carbonyl compound. So this compound will be formed. Okay, so next, in the next step, what will happen? Formation of the ester amine. So from with another molecule of this one, your beta ketoester, ammonia will react to form ester enamine. So here you see it will form ester enamine. So it is ester, then en means double bond, amine, and H2. So it will form ester enamine. So in the next step, what will happen? For this ester enamine and this unsaturated carbonyl compound will undergo condensation or Michael addition reaction, not condensation, Michael addition reaction. So here this double bond of enamine is attacking this one. Okay, so ultimately it is forming one bond here, okay, with carbon. So this carbon with this carbon is forming one bond from here, okay, and this is coming to this place. So you see double bond, then this oxygen is getting the negative charge, okay, because of formation of this double bond. Then nitrogen acquire the positive charge because of breaking of this double bond, okay. So NH2 positive. Next, ammonia will attack, 2 molecule of ammonia will attack. So there will be tautomerization along with that one. So overall this double bond electron is taken by this H, okay. So there is single bond now, okay, single bond, and this H is taken by this NH3, okay. So here it is getting again, it is getting double bond, okay. After removing of this H, it will form the double bond. So it is again getting its original state, okay, NH2 here, C double bond O, okay. So next, what is happening? Nucleophilic addition. So nucleophilic addition is taking place here. So H and OH will come out, okay, after nucleophilic addition. That means this NH2 is a nucleophile, so it will attack this carbon, okay. So nucleophilic addition reaction, so attack this carbonyl carbon, so it is forming NH bond, okay. This is forming NH bond. So after forming this NH bond, this OH will be there. H will, one H from here go to O, so it will form OH. So from one H from this place and OH will come out as a water, dehydration will take place, so to form this double bond. So this is the dihydropyridine, okay, dihydropyridine. So next, what will happen? Oxidation will take place in presence of HNO3 and H2SO4. So after oxidation, okay, it will form this compound, okay. Aromatic pyrimidine ring will be formed, okay. That means from non-aromatic compound it will form aromatic pyridine compound. Then next, potassium hydroxide in ethanol, so it will just remove C2H5OH. C2H5OH will be removed, okay. Then next, you heat that one with calcium oxide, so calcium oxide will remove the 2 carbon dioxide to ultimately give you the 2,6-dimethyl pyrimidine, okay. So you can write the reaction up to this one also, it's okay, no problem. Ultimately you are getting the pyrimidine ring here also, but if you want to write till this 2,6-dimethyl pyrimidine, it is also okay. There is no wrong in that reaction, okay. Next, the GuRSC synthesis, next method of preparation of pyridine. So modification of Han synthesis, use of cyanoacetamide as the nitrogen containing component. So there we got from NH3 we got nitrogen, but here cyanoacetamide is used as nitrogen containing compound. So this is in presence of K2CO3 acetone, heat it, you will get the compound 2-pyridone, okay, 2-pyridone. Then next, or you can directly use this one, 3-alkoxyenones and enane nitrile, okay. So in presence of K2CO3 and acetone, heat it, you will get the compound, this one, this compound, okay. So it is a pure, here it is pyridone because of the this C double bond O, but here it is, you are getting pure, you are getting substituted pyridine ring, okay. So next, from 1,5-dicarbonyl compound, so ammonia reacts with 1,5-dicarbonyl compound, so it is 1,5-dicarbonyl compounds, 1,5, okay, 2, 3, 4, 5, 1,5-dicarbonyl compounds to give 1,4-dihydropyridine. So this is 1,4-dihydropyridine in presence of ammonia. Then you just do, which are easily dehydrogenated, you do just do oxidation, that means addition of oxygen or removal of hydrogen. So you just remove hydrogen from these two places, one hydrogen from here, one hydrogen from here, in oxidation in presence of HNO3, so you will get substituted pyridine, okay. Then next, Kondratreva pyridine synthesis. So you already studied this synthesis under the reaction of oxazole. There in the reaction of oxazole, you are using oxazole for synthesis of pyridine. So synthesizing pyridine derivative by dialcellular. So it is dialcellular cycloaddition reaction. You know, this is acting as a diene and this is dienophile. Okay, between an azadiene and a dienophile, followed by an extrusion of the resulting bridge of the bicyclic intermediate. So one molecule of water will be removed and ultimately you will get the compound pyridine. Okay, so you just mechanism you refer to reaction of oxazole. There I have already discussed in the video where I have you have studied the reaction of oxazole. You will get the this conductiva pyridine synthesis. I have given the mechanism. So I hope you have understood. Thank you.